Hi everyone, we are going to cover the topic of one-sided limits, and we will cover the topic of two-sided limits tomorrow. All right, taking a look at this, you can see that we have a piecewise function, and if you look at 2, think about the fact that when we look at what is happening to our function from the left, right, see how my arrow is coming from the left side? My y value is actually approaching 2. However, when I approach this blue function from the right side, see how my arrow is coming from the right, it's actually approaching the y value of 1. And so I've just discussed one-sided limits, talking about a limit from the left and a limit from the right. And that's what we're going to tackle today. Before we do this, I do want to review how to graph piecewise functions. We did this in pre-calc, and it was a little bit of a challenge, but it's important to be able to do this so that we can tackle our one-sided functions. So first of all, let's go ahead and let's graph x squared minus 4. And if you think about what the graph of x squared is, right, if I have x squared, that's going to be 0, 0, 1, 1, 2, 4, 3, 9. So I'm just going to graph that really quickly. 0, 0, 1, 1, 2, 4, 1, 2, 4, and 3, 9. I'm not going to do 3, 9. But you should also know that minus 1, when we square that, we get 1. Minus 2, when we square that, we get 4. Minus 3, when we square that, we get 9. And so it's just a reflection. Sorry about that. So we have this value here, and then we have this value here. Now that's the graph of x squared, like that, but notice how it's asking me to graph x squared minus 4, which means I'm just translating it down 4 units. So I'm going to take every single one of those points, and I'm going to go down 4 with it. So this one right here is going to become down 4 of 1, 2, 3, 4. This one here is going to go down 1, 2, 3, 4. This one goes down 1, 2, 3, 4. 1, 2, 3, 4, go down 1, 2, 3, 4. And then I'm going to go ahead and erase my previous mark, and I've got my x squared minus 4. Now, we also have to keep in mind that we have some restrictions on our domain, on our x values. We're just talking about x being less than 3. Okay, so that means that everything to the left is going to stay. And it looks like I actually have no 3 value inputted here. So let me just go ahead and find out what that is. I'm going to take 3 and plug in, and I get 3 squared minus 4, which is 9 minus 4, which is 5, right? So I'm going to have the point 3, 5. I'm going to go ahead, I'm going to graph 3, 5. So there it is right here. Now you should also notice that it's less than 3. So actually, do we really have that point? Well, not really. We have an open hole at that point because it's less than 3. It's not less than or equal to. So I'm going to go ahead and redraw this graph. It's going to look like this. All right, there you go. All right, next thing I'm going to do here is I'm going to graph my line. And I'm going to graph the whole thing and then end up erasing what I don't need. And I know this is a little easier on what I'm using than it is for you with the pencil, but maybe draw lightly. So of course, to graph a line, we're going to start with our minus 5. So it's going to be down 1, 2, 3, 4, 5, right here. And then I'm going to go up 2 over 3, up 2 over 3. So up 2 over 3, up 2 over 1. 3. Okay, there I am. And I know that my values are going to be for x is greater than or equal to 3. So you're welcome to draw the line, but in reality, what we have is I only want to keep everything to the right of this value right here, because x is greater than or equal to 3, and this is my 3 value for x. So I'm going to erase my line, and I'm only going to keep everything to the right, just like that. And so this is a perfect setup problem. And we're going to do our first one here right now for one-sided limits. So I want to talk about example 1 here. I want to know what the limit as x approaches 3 from the left of h of x. And the reason I chose h of x is because here, I've got h of x. So I'm saying we need to start approaching 3, the value of x, from the left. Well, where is 3? It's right here, but we really just care about what the function is doing at that. So we're talking about approaching it from the left. So I'm really saying, okay, I'm coming from the left, I'm approaching the x value of 3, and the question's saying, what's the y value associated? Well, we've discussed this several times. It doesn't matter that this is an open circle. What matters is that it's approaching a value, and that y value it's approaching is this one right here, which is 1, 2, 3, 4, 5. So that is a limit of 5. All right, next one we're going to do is the limit as x approaches 3 from the right of h of x. Okay, so now I'm going to be approaching my function with my x value of 3, I'm going to approach it from the right. So here I am approaching that x value right here. What is my y value approaching? Well, it's approaching this number right here, which is a -3. And we're not going to discuss this yet. I want you to start thinking about it. But what do you think is true if our one-sided limits are not the same? The fact that this one is 5 and this is -3. We're going to deal with this tomorrow, but I want you to start thinking about what do you think the limit as x approaches 3 of h of x is, given the fact that our one-sided limits are not equal. So start thinking about that. All right. The function f has a right-sided limit or right-handed limit L as x approaches a from the right, written the limit as x approaches a from the plus, right? This plus symbol means from the right, of f of x equals L. So if the values f of x can be made as close to L as possible, you don't have to be equal to it, but if you can get as close as possible to a number, that limit does exist. So let's do this limit problem right here. I guess we're at example 2 here. What is the limit as x approaches 2 from the right, and we're talking about f of x. Okay, again, that plus indicates from the right. So I know that I'm talking about what's happening around this area in my graph, and I know I'm approaching it from the right. So I'm approaching it from the right, and what is my y value associated with that? It's 1. So that would be my right-handed limit. Now let's talk about the left-handed limit. You're going to see you're going to have this minus sign, which means left. And basically, if the values f of x can be made as close as possible to m, it doesn't have to be equal to, then we do have a limit. So let's do example 3 here. I have the limit as x approaches, let's say 2 from the left of f of x. Okay, so again, we're talking about this location because we're talking about an x value of 2, and I'm approaching it from the left. Okay, what's that y value associated there? What are we approaching? Looks like we're approaching 2. So our limit is going to be 2. And again, I want you to start thinking about the fact that our right-sided limit was 1 and our left-sided limit was 2. So the question is that we're going to answer tomorrow, what do you think the limit as x approaches 2 of f of x would be if the one-sided limits were not the same? All right. I got a little ahead of myself here. All right, so let's go ahead and let's look at this more practice. I want the limit as x approaches 1 from the left, and we'll call this graph f of x. I want the limit as x approaches 1 from the right of f of x. I want the limit as x approaches 6, just as a review. Let's do the limit as x approaches 1. We already did 1. We'll just do x approaches -4 from the right. The limit as x approaches -4 from the left. And last but not least, I want the limit as x approaches -4 just in general. So you might want to pause the video and try this problem on your own. Okay, hopefully you're back and you tried it on your own. So we've got the limit as x approaches 1 from the left. We're talking about approaching 1 from the left, right? My x value here is 1, and my y value here is going to be 4. What about approaching 1 from the right? Well, approaching 1 from the right, we're actually here, and my y value is -2. Limit as x approaches 6 of f of x. So approaching 6, let's see, I'm approaching 6 in this direction, approaching 6 in this direction. Looks like we're approaching the number of 5 right here. Okay, let's do the limit as x approaches -4. So I'm approaching here and here. Looks like it approaches the same number, and that number is 2. Okay, however, this problem just asks about approaching -4 from the right, so I only care about this right here, and the answer is still 2. And then approaching -4 from the left, here we are, and my answer is still 2. Kind of interesting that you can see that the right-sided limit, the left-sided limit, those are both 2, but so is the limit as x approaches -4. So start thinking about, when does a one-sided limit exist? When does a two-sided limit exist? And we'll certainly cover that in more detail another day. Thanks for watching, everyone.